Welcome back, students. We continue the polynomial chapter 9 exercise 9.1. In this class in previous class we just defined what is a polynomial and explained the types of polynomials. Here we start the exercise, that is 9.1. Again, one more definition regarding polynomials. Polynomials are some of the terms from k into x power n, where k is any number and n is a positive integer. So all these I defined. This is one more definition. So example is 6x 3x 6x plus 3x minus 8. Just an example. So now we'll start the exercise. So the exercise given is the graph of y is equal to p of x are given in the figure below. For some polynomials p of x, find the number of zeros of p of x in each case. So we have to find the number of zeros in each case. Here, see, the first diagram given in the problem is this. So what? So here the graph, just a line is there in this graph. This is x-axis, this is y-axis, and a line only just it is passing through this y-axis. And here we have to write the solution. The graph of y is equal to p of x. So this is just a line, does not intersect with the x-axis. So only y-axis, does not intersect with the x-axis. P of x, we have to write does not intersect the x-axis. So we can conclude this as no zero. P of x has no zeros or no zero. This is the conclusion. So next we move on to the second problem. Here see the graph both in x and y axis. A curve is there and one more curve is formed here. So this is a x and x dash, this is y and y dash. So where the x and y axis intersect is, here is one point, x-axis is at only one point, see here. So this one. So what is the conclusion? The number of the graph of y is equal to p of x intersects the x-axis, intersect the x-axis at only one point. So this one. So number of zeros, the number of zeros is 1. That's all for this one. So we move on to the next, that is the third problem. We'll see what is the graph given here. So this is the graph here. So what are the 2 points here? Here 1, the number of zeros, 1, 2 and 3. 1, 2 and 3. The graph we'll write the conclusion of y is equal to p of x intersects the x-axis at 3 points. So as I showed you, 1, 2 and 3. So these are the 3 points. Therefore, the number of zeros is 3. Next we move on to the fourth one. So the number of zeros here is 2, 1 and 2. The graph of y is equal to p of x is 2. The graph y is equal to p of x intersects the x-axis at 2 points. So this is called a parabola. So points, therefore the number of zeros is 2. So now we move on to the fifth one. Fifth problem is here how many zeros? We'll see in this one. That is 1, 2, 3 and 4. 4 points or 4 zeros. So what is the conclusion? The graph of y is equal to p of x intersects the x-axis at 4 points. Therefore, the number of zeros is 4. So next graph. So number of okay, this is the fourth one, fifth, fourth, and then sixth one. We move on to the sixth one. So we'll see. So the graph. So the number of here is only. How many points are there? 3 points. 3 points. 1, 2 and 3. See here this one, 1, 2 and 3. So the conclusion is the graph of y is equal to p of x intersects the x-axis at 3 points. I showed you all the points. So what is the conclusion? Therefore, the number of zeros is 3. So this is the conclusion. So this completes the exercise, that is 9.1. So we move on to the next exercise, that is, these are the only problems in the exercise 9.1. We move on to the 9.2. So what is the exercise given here? Question 1. So this is the question given, Polynomials chapter 9 and exercise 9.2. Find the zeros of the following quadratic polynomials and verify the relationship between zeros and coefficients. So the first problem given is x square minus 2x minus 8. So we'll start the problem finding the number of zeros in the quadratic polynomials. This is given. Just write down p of x. P of x is equal to x square minus 2x minus 8. Now we have to just simplify this. So x square minus 2x minus 8. So minus 2x can be written as minus 2x is equal to minus 4x plus 2x. Substitute this in the above equation. Now what happens? X square minus 2x minus 8x can be written as x square minus 2 minus 4x plus 2x minus 8. Now we will take the difference, the common outside, x minus 4 plus 2 into x minus 4. Now we can write this one as x plus 2, these 2 and these 2 common, and x plus x minus 4. Now equate it to 0. Now put p of x is equal to 0. Now x plus 2 and x minus 4 is equal to 0. Now we can write this one as x plus 2 is equal to 0 and x minus 4 is equal to 0. Now x will be equal to minus 2 and x is equal to minus 4. Hence we can finally write as zeros, therefore zeros of the polynomial are minus 2 and 4. So this is the solution. Next we will continue verification, and what they have given in the question: find the number of zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. So we have to verify the relation between 0 and the coefficients. Next is, what is the next step? Next step is verification. So what is the sum of, this is the formula, sum of the zeros is equal to coefficient coefficient of x by coefficient of x, coefficient of x square. So now we'll see what was the equation given, that is p of x is equal to x square minus 2x plus 8 was the equation. Now we'll substitute coefficient of x is how much here, sorry, this is 2x, this one x square minus 2x plus 8. Then substitute coefficient of x is minus 2 and x square is 1, so nothing is there is assumed as 1. Then we get minus 2 by 1. So this is sum of zeros. Now one more verification is left, that is product of zeros. Product of zeros of zeros. What is the formula? Is constant term by everything I defined in the first introduction class. What is constant, what is coefficient, everything, and coefficient of x square. So what is the constant term here in the equation? This is the constant term, that is the number without the variable. So x, so we'll substitute here. What is constant term is 8. So I made a mistake here. This is minus, so this is minus the expression. Yeah, it is, I have written correctly, but here I made a mistake here, minus. So substitute the values, minus 8 by what is coefficient of x square? 1. Substitute, we get minus 8 by 1 as the solution. Therefore finally the relationship between the zeros and its coefficients is verified. So this is the solution for the minus 2 by 1 means this is minus 2 and this is minus 8. Then 2. Therefore this is the solution for the first problem, that is 9.2 exercise first problem. So we move on to the next one. So next problem given is, so 9th one. 4s square minus 4s plus 1 is equal 1 is given. Therefore f of s is equal to 4s square minus 4s plus 1. So now 4 minus 4s can be written as minus 4s can be written as minus 4s is equal to minus 2x and minus 2s minus 2s. Substitute in the above equation. 4s square minus 4s plus 1, 4s square minus 2s plus 1. Now take the common here. 2s is minus 1. Then here minus 1 into 2s minus 1. So take this expression. So in the both the case we get 2s minus 1 and 2s minus 1. Then put p of s or sorry f of s, or make it p of s. P of s is equal to 0. Then now we get 2s minus 1 is equal to 0 and 2s minus 1 is equal to 0. So hence the zeros of the polynomial or minus and off and off. So now verification sum of zeros. Sum of zeros is equal to sum of zeros. Coefficient, what is the formula? Coefficient of x by coefficient of x square. Now substitute the value. So what is the equation? Equation is 4s square minus 4s plus 1. So substitute coefficient of x is 4 minus 4. Then coefficient of x square is, this is coefficient of x, that is s minus 4. Coefficient of x square is 4, that is plus 4. Cancel this, we'll get minus 1. Then product. So add this coefficient, we'll get minus 1 minus, okay. Now product of the zeros. Product of zeros is equal to constant term by coefficient of x square is equal to, what is the constant term? 1. Then coefficient of x square is 4, that is equal to 1 by 4. So hence now finally, therefore the relationship between the zeros and its coefficients is verified. So this is the solution for the problem, that is second problem in 9.2 exercise. If you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.